Okay, so that you all work on your own computer and you don't all connect to the same computer to run OpenNet, we have a list. So I need you to go into the document that is on Moodle in general up here, and then you can find your student number and the computer that you are allocated to work on. So once you do that, if you go back to Moodle, you will find a guide, which is the A2.NET connection guide. Now, in order to connect, you need to have two things. You need to have the university's VPN running and connected. So if you go to, okay, yes. All right. Click on it. Oh, fine. So this is the guide for remote access, and it contains the software for you to connect to the VPN. All right. So next to go again, how to use it. And where's the VPN connection? Okay. Oh, it's here. All right, so you need to go here and install the VPN on Windows 10 or Mac OS or whatever you're using on. It also has a guide for Ubuntu if you are working on Ubuntu Linux. And I think it should be pretty much the same. No, it's not for CentOS. Okay, but you can connect to it from your home computer anyway. So once you have the VPN running, so if you're on Windows, it will show like a little icon down here, and you can connect to it. Once that's connected, you need to install X2Go. So if you go back to this, then, well, essentially it's this guy right here. I'm having an off day, aren't I? You can wait, go back. Okay. And then you install X2Go. So X2Go, once it's installed, looks like this. Okay. And you can follow the connection guide that exists here. So this connection guide tells us what? So you are connecting, I will explain the process to you. You are connecting into the university. You're connecting through our gateway, which is SSH port ACUK. And then you're jumping at the same time to one of the computers in A2.NET. So how are we doing this? You create a new session next to go. And what we have here is, so you give the session a name. So I named it Shumi because I was trying to connect to my computer in the lab, but there's something missing from it. So I'm connecting to another one instead. So what you need is a name, which is the name of the computer that you're connecting to. So if you want, you can use the computer name from this list of the computer that you're going on to. And then you need the host. The host should be called VLAN something. So it is wrong here, and I do plan to update the guide. So following these instructions, oh yes, you can also use this to connect to Rinat's class, by the way, if you have a class with Rinat. So VLAN 126 is the host name. Login name, for me it's VAS, for you it's going to be UP and then your student numbers. And then you're using SSH and you are using a proxy server, which is SSH port ACUK. Same login as X2Go server for both this and this, and you click OK. So what happens is when you double click on it, it asks you for the password. And after a while, sometimes a bit longer, it will connect. Okay, so this is something that you don't need to worry about. And I mean, once I'm in, I can run OpNet, and I'm there. Okay, so can I ask how many of you have any of this? So do you have like the VPN installed and the X2Go installed? Have you done this before at all?
I've got the VPN installed, but not X2Go.
Okay,
I haven't, because last year I had uni internet, so I didn't have to VPN in.
okay, that's good. So what I would like to do today is I would like to take the time for you to actually install everything. Okay, so I would like you to go on to Moodle and follow the links and download and install the VPN first. And once you're connected to it, then download and install X2Go and configure the session according to this. So I will leave my session, let's see, this one, preferences. So I will leave this running like this so that you can see exactly how I've configured mine. Okay. And you can go on to your Google Doc and find out which computer is actually the one that you are connecting to. Okay. I'll give you about 10-15 minutes to do this. If you need anything else, let me know. I will be here and I can listen in. All right. Stop sharing. And I will pause the recording while we're waiting for this. All right. Okay, so hopefully most of you or the vast majority of you have connected so far. So what I have today is I have lecture slides and I have a couple of lab sheets as well. So I need to share my screen again. And I can get this out of the way. This guy stays down here and we are here. Okay, this. Right, so the whole purpose of this unit is for you to learn, I would say, network optimization. Okay, network customization, optimization. The easiest way for us to do this is through the use of a network simulation software. We're using OpNet in our case, and we're going to learn what the basic components are for it and how we actually simulate networks. Okay. So the first lecture is on devices in an internet connection. So what do we actually need? So we start with, my arrows do this. Okay, good. So we start with some abstraction. So we need to identify attributes. So what are the bound attributes? So let's say, for example, you have a network. Okay, why would you simulate it? What are you looking for? What are you doing? Usually, you will either be in one of two cases. You will have a brand new network that needs to be built, or you have an existing network that needs to be upgraded. If it's a brand new network that needs to be built, you need to know what the purpose in life will be of that network. So you need to know what that network will be used for. So for example, if you're building, let's say, a gaming server, and that needs to go out on a national scale. So essentially, you're building something like an ISP that specializes in gaming applications. Then you need to know what sort of latency would be adequate to your network. Okay, how many milliseconds of delay as maximum you would be willing to accept for your packages. So one attribute could be latency. Or let's say, for example, that you're building a CDN server or data center for Netflix. Okay, you need to know how much storage space you will need, how much processing power in all the storage servers, what sort of bandwidth, how many simultaneous connections you have to support, and so on and so forth. So these are all the attributes of examples rather of the attributes of the network that you will be building. They're highly dependent on the context of each of the objects, and it will help us identify what is really important in the simulation. So networks will have lots of attributes and lots of invariants. So you will have, for example, your hardware. So you have your server, you have your routers, you have your connections, all of the links between everything. But you will also have users on them, and the user's behavior is something that you have to estimate or guesstimate rather, okay, rather than being able to calculate precisely. So that's what the invariants actually are. So you have attributes that you know and are fixed, like your hardware, and you have attributes that you cannot know, but you can try to estimate, especially with the longer the time goes by, the more you use the network, the better estimates you'll be able to make. Experimental design, how does it work? We start with a hypothesis, we derive a methodology, and then we go and perform an analysis. So the hypothesis is based on what are you looking for, what questions do you want to answer, and the study of complex systems. So as I said, you're running a simulation, you're creating a network. Why are you creating it? What do you want to see? You come up with a methodology. So you make deliberate and purposeful changes to your system and observe the effect of those changes. So let's say, for example, you have a network and the hypothesis is, can you make it faster? Okay. So in the methodology, we try to come up with different scenarios of the project that would make it go faster. So perhaps implement some quality of service or some traffic shaping and so on. Once you come up with a methodology, you create your simulation, you run it, you have the analysis. So you analyze the results. You must understand the system to do this, and you must understand what are the reasons for all of the variations that are happening. Is it something you did? Is it something that's inherent to the system? Can you explain everything that's going on in the simulation? And most importantly, can you get out some meaningful results, some meaningful conclusions with regards to your hypothesis from the simulation that you run? So the whole point of simulating a network is to be able to find some answer to a question. Okay, it's not going to be a purpose upon itself to just run a simulation. Reasons for simulation, you might need to analyze, for example, impacts of different network designs, different topologies, different technologies used, different equipment, different algorithms, like let's say different routing protocols or different networking configurations. You might need to analyze some technology benchmark and create a comparison, something new that has come out, or you might simply need to just gain understanding of how a network actually works. So after you've implemented some protocol, perhaps you want to see how the routing protocol creates the routing tables and how it shares information with all of the routers next to it and how fast they will build the routing tables and so on. Many of the current protocols and devices were developed through simulation. I think I need to change that much at some point in my life. It's been there for years. Simulation outcomes, insights to design. So you get to understand more things in detail, like traffic and technologies that are used. You have some confidence in the evaluation of what you're looking for. So does the topology, for example, fit with the characteristics? Is the technology used appropriately? Are the algorithms that we're using, like routing algorithms, for example, effective and efficient to actually work for the type of traffic that we want to be using? Very importantly, can we predict future events? So if a network is being used like daily, weekly, monthly, and so on, can we predict if it will eventually be saturated and we need to have some contingencies in place? Failure, for example, node failure in the future, and so on. And will the current design scale? So if you do have more traffic or more users, what can you actually do to make it better, to make the network better? Of course, at this point I have to say, although it goes without saying really, that the whole benefit of running a simulation of a network is that you don't actually have to go and buy equipment and test it live. Yes? So if you have a network that supports 10,000 users and your company signs a contract to cooperate with another company and suddenly your users will double in the network, you can have a simulation running of your current network and make changes and see how much more equipment, how much more bandwidth, how many more routers, how many workstations it may be you will need in order to make the network work by spending a minimum amount of money doing that. Okay, yes. Advantage of simulation, so flexibility to choose desired time and time accuracy. So you can run a simulation for as long as you like. The only constraint would be the CPU power that you have to do this. It's not limited to analytical or trackable mathematical models. You can design it to do whatever you want it to do. You can come up with your own new routing protocol if you want it. You can get alternative system design, which is an easy to evaluate because you can see there and there what's happening without actually building the thing. You can get alternative operating conditions and policies for existing systems, so you can fine tune your network and see exactly what the changes, what effect the changes will have on it. And of course, you can keep control over the experimental conditions. So whatever it is that you're doing on the network, you're changing something. Everything on the network depends on the parameters that you set during the simulation. You won't have any unexpected problems in the simulation. Disadvantages, it's only an estimation of model's true characteristics. It might not be 100%, or you might not actually have the exact model of the router, let's say, for example, available for you to use. So you have to approximate. Development can be expensive and time consuming because, yes, simulation programs software is usually quite expensive. Of course, not as much as buying the actual equipment, but still. And it will take quite a few man-hours to create a network, build it, make the changes, and simulate. So it can be time-consuming to run simulations. It depends on the statistics you choose to view, the amount of data, and the length of time you simulate for. So obviously, if you have a network that has 10 workstations and 3 routers connecting them, then it will simulate very quickly. But if you have thousands of users across multiple countries, across multiple networks, then that will take a long time to simulate. And that is mainly the reason why the computers in our school, or specifically in RVC, let's say, on second floor, they are all like 8 cores here with so much memory and SSD. Okay, because we're running CAD software, computer-aided design software, and not just computer network design, we have other sort of programs as well, like MATLAB, for example. Persuasive impact of large volume data, so use of statistical inference. So you can run a simulation, you can collect so much data out of it, but in the end, you will almost not know what to do with it. It depends, so you need to do some statistics and make some meaningful deductions out of that. And it gives you a lack of insight into underlying laws. So when you are making a simulation, if you are a network engineer, you might not know all of the underlying laws that might bring in some limitations to your design. So that might be a problem later on. Okay, let's make that button again. So these are basically the ideas behind running a simulation, simulating a network. Okay, I don't know if it shows. I don't really like presentations. I don't like PowerPoint slides and all that. What I do like is this. So we have 2 lab sheets. I will do the first lab sheet here with you today. So I will run it and I will screen share it while I'm doing it. Okay, so that you can see exactly how I'm using the program and get some ideas on how you can use it. And where's my session? Here it is. Go. You can still see my screen, okay? Yes.
Yes.
Good. So, best way to do this. Let me log in again. So, have the lab sheet open on one side, and then have your X2Go session running on the other with OpenNet running onto it. The labs are step-by-step instructions. If you miss a step, especially later on when the configuration gets more complicated, then you will have problems. What you want to not actually happen in the end. Okay, so you need to. I would always recommend that you read all of the lab sheet once from beginning to end. Okay, so that you understand exactly what it is that we're doing, and then start doing the lab sheet step by step. So this whole idea of knowing what the forest looks like before you just start working in the tree. All right. So the
Sorry,
purpose
just
is,
to clarify, so
yes.
as we're doing this,
Uh-huh.
we should be filling in the logbook as well.
You don't need to keep a logbook for this unit. This unit is marked on coursework and then a Viva. Okay.
Okay.
So you don't need to have a logbook running for this. You can keep notes if you like. What I like to do is they are PDF files, but if you have the latest version of Office, for example, you can open them in Word. So if you open them in Word, once you do something, then you can highlight it and change color, like make it red, so that you know that you've done it, so that you know which step you're working on. So if we were old school, I would print this and put a little check next to each of the steps, just to make sure that I've done it. Okay. So this is perhaps the only thing that you need to do, or if you want to keep some notes about whatever you're doing, you can just create a logbook for yourself and keep it, and that's it really. It doesn't.
Okay, that's sorry.
Good. So this lab sheet number 1 is using OpenNet to generate traffic. Okay, so we're going to start OpenNet. We're going to see how we can create a scenario and so on. We're going to go through the most basic component that we need to use. Then we'll build a simple network in the fastest way that can happen. There are some tasks, so list what components make up that object and identify what they do. So node 0, you'll see what that is. I will show you later on. Then you configure the network node with traffic, you choose statistics, and you configure and run the simulation and have some tasks to answer after that. So let's go ahead and do it. Starting OpenNet, blah, blah, blah. So once we start OpenNet, click File, New. So File, New. So have the new window that comes up and says New Project. If at any point you get lost, I will try to go slow on this. Just speak up and let me know. Okay, and also know that I cannot see the chat at the moment because I have it closed. So just enable your microphone and interrupt me. Okay. So new, you'll be presented with the screen below. We'll always develop projects. So you should click OK to new project. And it comes up with this. Choose an appropriate name. So I'm going to name it Lab 1. And this is 2021, essentially. And also call the scenario something appropriate. For example, if you're doing experimenting with MPLS, you may have one scenario called with MPLS. Okay, so this is sort of an introduction to it. So when we go down here, it's File, New, Create New Project. I'm calling it Lab 1, and the scenario is going to be called Hub Problems. I'm going to call it Hub Problems. So in fact, actually, I think I should start at this point. So let me explain what's going on here. Generally, we have projects and they have scenarios. Okay, so you can have a project that's called, ISP, whatever, and then you can create different scenarios into it that you make little changes to the network. So let's say you create your network, you create the topology, you have the users, you have the traffic, you implement whatever routing you need to implement and so on, and you want to change something. Let's say you want to change the routing protocol from, let's say, RIP to OSPF. Okay, so what you do is you duplicate the scenario, and then you go in the second scenario, you name it OSPF. You make the change, and you run both scenarios. You look at the traffic on a specific link, for example, and you can see what difference there is between the two scenarios in the same project by using different routing protocols. Okay, we have different sizes of network that we can have, world, enterprise, campus, office, and so on. And then the most important devices that we usually use are the subnet. So this is a component that can be used to group together network components. So basically, if you're building a city, you should create a subnet and then put everything that's in the city in there. We have an application configuration. This is the component that we use to define the applications that will be used on the network. HTTP, FTP, whatever else it is that you want to be using as an application. You then have the profile configuration block, which tells us exactly how each of those applications will be used. So it will create user profiles. You have an IPQoS box. So this is the component that's used to specify various quality of service attributes. Okay. You have something like a hub, so Ethernet 32 hub. So that's essentially a hub with 32 Ethernet ports. So all the names actually mean something in the devices. Okay. So Ethernet 16 switch means that it's a 16 port Ethernet switch. You have an Ethernet 4 sleep 8 gateway. So that's a gateway router essentially that has 4 Ethernet ports and 8 serial line ports. You have an Ethernet workstation, which is just your normal run-of-the-mill computer. You can have a LAN. So that is essentially a LAN that includes a switch and 10 workstations by default. You can change the number of workstations if you want. There is a weird one. There is an Ethernet station. This component has no TCP, UDP, or IP stack. So it's essentially pretty much a traffic generator. Okay, it creates on-off traffic that just comes out of it, doesn't follow any protocol. So if you're just saying I want to send 64 kilobytes down a link, how fast do they go? You can use something like this. There are various links, various cables that you can use, Ethernet, PPP links, whatever, it all depends on the scenario. And you also have traffic flows. So this is a logical way to generate traffic without configuring applications. We'll see later on how we use this. So let's go on to building a simple network. So open it, new, lab 1, hub problems. Click OK. Startup wizard. So what are we looking for? Empty scenario, click on Office. So let's create an empty scenario, click Next, select Office, click Next, and set the dimension to something if it's relevant, and then click Next. So 100 by 100 meters for an office, it's a bit much, so I'm going to make it 50. Okay, click Next. And then click Next and finish again. So this is to select the technologies that will be used in the simulation. By default, if I remember correctly, it uses the internet components. So we'll see that come up. Once you click Finish, then the object palette shows up. So let's see if I can make this bigger. Or if it will really complain. Okay, that's good. Okay, so this is my object palette. So I'm gonna make this a bit smaller so that you can see everything that's happening. Okay. So now we're dragging and dropping components into our simulation if we want, or we can use another method. So let's see what we're doing on this one. So you should now be presented with an empty network domain workspace, which is all of this, and an object palette, which by default opens up on the Internet Toolbox, which is what we see up here. Okay, so it creates a palette that contains the most basic models for the simulation. It gives you a selection of objects to bring your own. So left click and select an object, let's say Ethernet workstation, and drag that object onto the network domain. So let's see, Ethernet workstation, drag and drop. Yeah. So that's not right. Oh. Okay. Right. Does anybody else have a simulation running? Is it just me?
I think so far it's just you. Do you want me to try and start something?
Somebody please, yes, to try it. Start.
I got one running.
Okay, so can you open it, create a project, and just drag and drop some devices in there, see what happens.
Do you think it could be a licensing issue?
Oh, no, that's going to be a graphics problem. I just want to see if it's on my end or if it's something that has to do with X2Go, or if it's a university problem.
For me, it's working correctly.
It is. Okay. So it might be an issue because I resized my window. It's dragging and dropping the wrong components. So Ethernet workstation, come on. Okay, so it is because I dragged and resized my window. That's great. Okay, so what can I do? All right, I have to click on the window all the time. Fine. So, what does it say? Ethernet workstation dragging into the network domain. Remember, the network domain is distance dependent, so it does matter where you put each of them on. So if you right click on the object, you have just put in the network domain, node 0, and click on edit node model of that object. So we are working on Ethernet workstation. I think I know what the problem is now. Ha! Okay, if I have anything else other than X2Go running, it messes it up. So this is the node, this is the workstation. If I right click and edit attributes, these are the sort of attributes that I can get for it. So these are the things that I can change, the information I can change into it. Right click, and edit node model. So what the lab should want us to do is edit node model. So edit attributes, edit node model. Yes, this lovely thing. So this is what the model actually consists of. Okay.
Hello, Faz.
Yes.
Sorry for draw us back. Please, I'm having problem to install S2Go on my system.
Okay, why? What does it do?
I can't even find where to install it. I've installed Global Connect, but I can't install. I don't know where to find S2Go.
So X2Go will be on that same link on Moodle. So when you're on Moodle, if you go to connection instructions,
okay,
then if the VPN is here, then global, X2Go is on this one.
okay.
Okay.
Yeah.
Good. There's something in the chat as well. Yes, that one. Thanks, Ben. Right, so back to it. So this is, how does it actually explain it in the lab? Let's see. List the components that make up that object and identify what they do. That's going to be a bit tricky. So essentially, you have the CPU, you have everything that processes everything, you have the application layer, you have the protocols that can be used, you have RSVP, you have UDP connections, you have RIP, you have DHCP, you have the MAC address, and so on. So all of these can actually double click on them as well. So each of these are finite state machines. Okay, so if something happens, do something. If that something happens, do something else, and so on. So what's inside of these is code. Okay, so it's a type of C that OpNet use. They call it Proto C, if I remember correctly. And mostly consists of an if, else, and so on statements. Okay. Now, this all might look a bit scary. However, the good news is you will never have to deal with this. Okay, at least not for the purpose of any purpose of this unit or anything else that we do in the university. I just wanted to show you what the underlying principles are, how it actually works in there. Okay, so it says what? Double click on a component and look at the state transition diagram, and this shows you the logical function, and then its state has some entry and exit code. Let's go to see everything else, and I've explained you this. You can put other nodes in the workspace and see what components they are made up of, and you can change the palette that you're using, change the selection of objects as well. After you are finished identifying the makeup of various objects, delete all objects from the workspace. Very simple, select, click, delete, and it's done. For this example, we're going to create a network using the topology creator. Select topology, rapid configuration from the main menu. So let's go topology and find rapid configuration. Okay. So rapid configuration. And choose a star configuration. Click next. From select models, choose the Ethernet model. Select model. We want Ethernet. Okay. And then what's next? The center node for this experiment is going to be an Ethernet 16 hub. That's that. And the periphery nodes, 16 of which will be Ethernet station. Periphery nodes, Ethernet station, and we want 16 of these guys. The connections will be 10 base T. Okay, you should now have a star network located in your workspace. Hooray. Okay, so have our hub, our links, and our nodes, our workstation. Configuring the network nodes. You will configure all the nodes in your network to have the same properties. Rather than setting the properties of each individual node, you can do this automatically. So right-click on any workstation and click Select Similar Nodes. This guy, right-click, select Similar Nodes. So we see now that all of the stations are selected. Right-click on any of the nodes that are selected and choose Edit Attributes. Okay, so I think it's only the dragging and dropping that messes it up. So I think the rest I should be able to do it like this. So Edit Attributes. You will be shown the Nodes Attribute box. It's from here that you can configure any node attribute, traffic generation, router configuration, etc. In order for the changes you make to this node to be applied to all other nodes, you must check the Apply Changes to Selected Objects box. So this is something that usually gets forgotten in that situation. Okay. So expand the traffic generation parameters. Yeah, expand it. Okay. Set the on state time to an exponential distribution with a mean of 100. So on state time, exponential with a mean of 100. Click OK. And the off state time to a constant of 0. So off state time, change it, constant of 0. Okay. In the packet generation arguments, set the inter-arrival time to a constant of 0.02. So packet generation means inter-arrival time constant 0.02. And the packet size to a constant 1500 bytes. Packet size constant 500. Okay. When you click OK, the parameters should have changed on all the nodes. Check this. So if I click OK, 16 objects changed. So it will tell you at the bottom of the simulation workspace. Okay, so this is verification that the changes that you've made happen to all of the nodes that you select. Choose statistics. Before you simulate the network, you must choose which statistics you want to record while the simulation is in progress. If you right-click anywhere in the workspace, but not on any of the objects, okay, you can choose individual DS statistics. You can select the statistics that you want to obtain from all of the nodes on the workspace. So, if you expand the global statistics box, select Ethernet, and let's go for delay, and then traffic received from traffic sink and traffic sent from traffic source. So traffic source and traffic sink. So the traffic source, we need to have traffic sent, and traffic sink, we need to have traffic received. What I want is in bits per second, rather. Okay, so traffic received, bits per second, and traffic sent, bits per second. Expand node statistics and Ethernet and select collision count. So we have node statistics, Ethernet, collision count. Click OK. And then we can configure the simulation. Now to run the simulation, we click on the running guide. Ingenious, I know. Set the duration to 3 minutes. Okay, what I also like to do is I like to change this to optimized 64-bit because that's the fastest way that it will run. So if I click apply and run. So now it will compile all of the models in the node, all of the models in the simulation. And now it's done. So we can go to results browser. How much traffic does each node generate? Let's go to, let's say, object statistic, office network, node 0, Ethernet, collision count. Then we go to global statistics, traffic source, traffic sent. Okay, 9,009.5 million bits per second. Okay, 9.6 megabps. So this is the traffic that's sent. So how much traffic does it node generate? This times 3 minutes. Okay, so if it's 9.6 megabps per second for 3 minutes is you do the multiplication, it comes up. How much traffic is transmitted in the network? So we can do what? We can go to traffic sink, traffic received. So if we deselect this, we can see that it's not a straight line. There are some peaks and troughs. Okay. If we go to Ethernet, we have delay. So let's see. Ethernet. So we can see how much traffic is being received on any given point on a traffic sink. Okay. What's unexpected in the results? So let's see. Traffic sent, traffic received. We can have the statistics viewed as stack, but we can have them as overlaid as well. So now we can see that we're sending out traffic source, traffic sent is the red line. We're sending out 9.6, but we're only receiving a bit more than 9. Okay, so we've lost almost 500 kilobps along the way. What's unexpected in the results is we're losing traffic. Why is this happening? Any ideas why? Any takers? We're receiving less traffic than we're sending. So some traffic is lost where? Where could the traffic be lost?
In the central node, because there is too much traffic to process at the same time.
Is it because there's too much traffic, or is it because it's a useless old hub? Yeah, it's not a switch, it's a hub. Do you know what the differences are between a hub and a switch? A switch will have some sort of queuing mechanism, whereas a hub would only do first in, first out on a round robin. So it would receive the data from somewhere, send it somewhere else, and while it's sending it somewhere else, all of the other data that's being received is simply dropped. Okay, so it is because of the hub. So if we go to, where was it? Collision count. So what's the node? The node is node 16. So if we look at node 16's collision count, ta-da! Okay, Whereas if we looked at anybody else's on one of the Ethernet workstations, very, very little. All right. But compared to the collision count on the hub, it's a lot. All right. So this is happening because of the hub. What effect does changing the on and off state times, interarrival time, and packet size have on the system? So what we're doing is, if we go, let's say, select similar nodes, edit attributes, traffic generation, and in fact, I can scenario, duplicate scenario, have problems. Let's call this bigger packet size. All right. And I spell it correctly as well. That would be great. So on this one, select similar nodes, edit attributes, apply to all, traffic generation, packet size, constant 1500. Let's make it 1500. If I run this now, everything else will have been kept the same results and everything else. Simulation completed. So results browser, I can now go, instead of current scenario, I can go current project, and I can compare. So let's say, for example, if I go to object statistics and look at my hub, and look at the Ethernet collisions, what did I do wrong? I didn't apply all the nodes. Let's see. Rookie mistake. Of course. All right, so exchange, because I haven't made any changes. All right, well, perhaps it's too much. So wait, let's go for 3000. Apply to all of them. Thing on the change. Okay. Run this. Ah, oh, come on. Okay, so something is wrong. So there is no traffic going around, right? So if we go to global traffic source sent. Oh, there is. Okay. So now traffic is being sent, but nothing is being received. Why? Because it's too much for the hub to handle. Wow. I've never done it before, by the way. So yeah. Nine. Collision count. Nothing. Well, that's very interesting. Okay. Let's eliminate it being a problem with OpNet or me having done something wrong. So this is the second scenario. And I'm going to change the traffic back to what it was. See if we get the same results as before. Like all. Okay. Yeah, so we can see the simulation progressing now, whereas before it wasn't. That's weird. So now we should be getting the same result as before. Okay. Ah, okay. That's weird, isn't it? So all we changed is the packet size. Is there a limit to how much it can take?
Is that a switch in the middle or a router that's connecting everything?
It's a hub, and it's. I mean, I would expect it to drop, but I would expect to see like a huge number of collisions on the hub happening.
Yeah, that's what, if it's a hub, maybe the packet size is literally just colliding everywhere, like train
It
crashes.
show us the collisions, yes? Wow. That's really weird. And then let's go the other way.
Or maybe the network's so congested that none of the nodes are even receiving packets.
Yes,
Maybe that's why they're not.
But if that was happening, then we should be able to see it, you know?
Mm.
And now I messed it up. Let's go for 70. Okay. It's really weird. So, current project. Let's say object statistics. And Ethernet collision count. Of course, I need to select the other scenario as well. Yes. So, with smaller packet size, essentially, not bigger, because we changed it from 1500 to 750. So now that the packets are smaller, it starts with actually more collisions at the beginning, but then the collisions actually go down later in time, and then the network will eventually reach an equilibrium that has much fewer collisions that will pretty much match the collisions that you get like on any given node. Okay, and this is it. It's really weird about the packet size that you didn't accept it. Yes, and if we look at traffic sink and traffic source, so the traffic that's being sent out, the traffic that's being received. Okay, so let's say traffic sent in bits per second. We have problems with the green one, and then the blue one is traffic received in hub problems. So this is the first scenario, and this is the second scenario. So you can see that the red and whatever should be light blue behind it here is essentially the same. So if I get hub problems out of the way, so these two lines are identical. Okay, so with a smaller packet size, so with half the packet size, we have almost no lost packages. If I zoom into this, so if I show and make it bigger and zoom in, we see that they are actually different. So, but the little tiny variations are down due to the very few collisions that are happening in the hub. Okay, so not identical, but they're very close to each other. And because this is a smaller packet size, that's why it's happening. Okay, so if you want, when you build the network yourselves, you can try changing the on-off state times and the arrival time and so on. Okay, so this is the idea behind creating a network and simulating. So you get some results and you run some analysis out of them. The analysis of our results tells us that hubs are crap, and we knew that because nobody ever uses hubs anymore. And if we are going to be using a hub, we should be using it only for communications with a smaller packet size if we want them to be efficient. Okay, So these are the sort of results that you can get out of a simulation like this. Save. So what I would like you to do until next week was I would like you to do lab 2, the generating traffic. So I want you to have a go at both labs with yourselves. Okay. I will do lab 2 in the class as well next week because it is setting up the applications and the profiles. It's very important that you understand exactly how this works because this will be the primary way that we will configure applications, that will configure traffic in the network. As you can see, there's a bit more configuration to happen here, but once I explain what everything is and how everything works, then it is pretty straightforward. Okay, so any questions about all this?
Yes, I've got a question.
Go on.
If we had a switch instead of a hub in that situation, we would have had much better traffic flow and whatnot. But also, if we then put half the computers on one subnet and the other half on another, will we get even better traffic flow? Or not really, because it's all going through the same node anyway, isn't it?
Well, it won't matter because remember, these are internet stations. They're just on and off traffic. Yes? So
Okay, yeah.
you can do these separate, you cannot do network segmentation and stuff like that. If
Yeah,
the
that's true.
internet workstations, perhaps yes, but only for huge amounts of traffic. So for 1.5 kilobytes per second, not really. It wouldn't matter. Okay. But
All
you
right.
get zero collision, zero drop packets, and the traffic would be identical no matter how much traffic you put on the switch. I think only for ridiculous amount of traffic, you would start having, traffic drop on the switch.
Thank you for explaining that.
Yeah. Right. Any other questions? Anything with regards to connecting to the university and all that? Have you all managed to connect, or is there anybody that's had problems with X2Go, for example?
I see. I'm on the. I want to firstly ask that after the lecture, are we going to be able to log in and practice the lab? That's one
You
question.
can log in. Sorry, I forgot to mention this. You can log in whenever, 3 o'clock in the morning, if you like. Okay. The
Okay.
computers are always open, and you can use them whenever you want. The only thing that might change is how many users will be on the computer. So the easiest way for you to do this, let's see. If you log into the remote computer, open a terminal and type who, it will tell you who's connected. So if you see other names there as well, it means that other people are using the computer as well. So if you want to run something that is CPU hungry, then I would recommend that you leave and come back later.
Okay. So about my login now, I want to ask the login.
Yeah.
On the note, you said it has been allocated.
Right. So the best thing to do once you're finished with the remote connection is go to system and do log out. Don't shut them down, because if you shut them down, you shut them down. Yes, we cannot connect to them remotely again. They are physical computers, right? So just log out, and that's it. The session will end. It will probably come back again with a login name. And and next time you want to log in, you just type in the password and the username and just click OK and it will log you in.
Okay. Okay. Thank you.
Okay. Anything else? Okay.
All good for me.
Okay, great. All right, thank you very much. If somebody has a problem and needs me to help them with it, they can stay behind, share the screen and show me. Okay.
Yeah, Lawrence is having some issues, but he's typing in the chat.
I can see them, yes. So cannot connect to proxy server. If you cannot connect to proxy server, it means that you typed the proxy server wrong, and it should be SSH port AC UK. Lance, if you want, you can share your screen with me, and I can have a look and tell you what's wrong. So the command to see if anybody else is on it is simply who. Okay, so all right. Okay, so so this is very wrong. So the host should be VLAN 97. So change that. where it says server on the top. No, this is fine. Go to the top where it says host. Instead of 10.1.197, it should be VLAN 97. Your login should be UP and then your student number, UP905.192. And then you can check the boxes that say same login as on the X2Go server on the right-hand side and same password as well. So tick both boxes. Yep, this should do it. Click OK.
He's not connecting via SSH. He's connecting via HTTP.
Oh, okay. That's what was different. Okay, thanks, Ben. Well spotted. Yes. All right, type in your student password. Now the resolution that you get will be very small, 800 by 600. So connect now to see that it connects, but then later on change it to something else. Yes. Yes. So later on change the resolution to something bigger so that it's easier for you to work on. All right, yes. It sometimes takes a while, so give it some time. There we go. Okay, you're in. So if you want to log out, just go to system and then log out, and that's it.
Vas, quick question. So we're doing like lab sheet 1 and 2 or whatever, right?
Yes.
That's now up to us to do that now.
Yes, please. Okay, anybody else? Everybody else connected, okay?
I have an issue connecting.
Okay, what does it do?
It just says like I sent you the error.
Okay,
I
yeah.
can show.
Can you share the screen and show us?
Yeah.
Is your VPN running?
It is.
Okay, so the VPN is connected. The VLAN SS8E port CDK. That's weird. So click OK. What does it do? Okay, so now I don't think you saved your changes though.
I haven't made any changes there.
Okay.
I was just showing my configuration.
No value for 10 and no -3. No, this is not understanding the connection session. This is not understanding the mate version thing. So click OK. Cancel this. Go to the
Oops.
You have
Sorry,
why do you have such a low resolution on your computer?
Yeah, I'm using my laptop.
Okay. Because there is an OK button down there that you need to push and you can't because you can't see it. It's under your taskbar.
Yeah.
So can't you increase the resolution on your laptop?
I can't at the moment. I'm
Okay.
afraid. Or is it auto hide?
Okay. Oh, barely. All right. So where it says custom desktop, click on it. And choose Mate.
Yep.
No, just click on drop down menu where it says custom.
Oh, okay. Sorry.
There. So click the light blue button. Yes, that should be okay. Okay, try it. Oh. Okay, can you try another computer? So click OK. And instead of VLAN 97, cancel this, go to the session. Change it to VLAN 96. Okay. Lovely. Okay. I don't know what this is.
I'll try and set it up later.
Okay.
See if I can get it
Your
working.
VPN is connected, yes?
Yes, it is.
Okay. Are you using Windows 7?
Yes, I am.
There might be some security, some authentication protocols and stuff that are out of date.
Mhm.
So that might be giving you the problem. Okay, so I've seen it before in older versions of operating systems. If they don't have all the security updates, sometimes it can do stupid things like that.
Okay.
But I don't know. You should be able to connect to VLAN 97 because we checked all the computers and they all
Yeah. Well, I've checked using PuTTY and I can still connect over SSH.
Okay. Well, if you are okay with using PuTTY and connecting, then you can use something like Xmink. If you're
Mm.
or
Yeah, that works still.
if you have like a Linux machine or something, whichever way you can connect, it's fine by me. As long as you can get OpenNet running on your screen.
Okay.
All right. Good. Thank you.
All right. Thanks.
Anybody else? All right then. That's it.
Hello. Hello.
Yeah.
Sorry.
Hello. Tell me.
I'm getting host key verification fee.
Because you didn't accept the key when it first popped up, you didn't say yes. So when the first time that you connect, it will ask you to accept an authentication key and say yes or no.
Okay.
So you need to say yes, because the public key authentication method, as I said, so you need to get a key first, and then it compares the two keys, one on your host, one on the.
Okay. I've logged in now.
Okay.
Thank you.
Yeah. Anything else? All right then. Thank you very much. I will stop recording now.